Okay, thank you everyone, and thank you for having me here. Just a little bit about myself. I'm a site reliability engineer, and I work at InfluxData. So my job, my daily job is to make InfluxDB and all the tech stack scalable. So I work a lot with AWS and Docker and automation. So I write about this on my blog, and that's the username I use around the net, so Twitter and GitHub. So just have a look at what I do. Other than that, that's what I like to do. So I make dirty hacks to look good, and I grow my vegetables, as you probably know. And I travel for fun and work, and I like it, so that's good. This was me in Cuba, just thinking about monitoring, because that's what I do when I see this view. So even over there, now that the view is really good, I was just thinking about monitoring. And I was kind of, the question was, let's think about the best word that we can think about. So where every developer is happy, all the code you write just run perfectly, so no bugs, nothing bad happens. All your infrastructure is just working, so all your servers are really good, no outage, the network is great, no latency ever, doesn't matter what you do, on how far you are, just nothing, you are in the paradise. In this world, somebody will care about monitoring. That was my question, so a really complicated one. And I kind of thought maybe we just use monitor to track bad stuff, to wait for the outage or to understand what's going on. But that's not true. I think that even in the paradise, we need monitoring. And not because we develop a time series database, so I'm not speaking for my company now, but because we care about what's going on. So if we are a purchase e-commerce company, we still need to see and to look at how many people are buying something, or if you run on AWS, even in a paradise, it will cost money, so we need to track how much it will cost. So even if everything just works, our monitor should be part of our domain. So what we can do is probably outsource it. So if it's not in our business and we don't have the effort to do that by ourselves, maybe we can outsource it, but it will still be part of our domain and our application. The instrumentation will still be there, even if everything works. So, come with me, my journey. What I'm going to tell you is about how at InfluxData we are developing our new cloud. So we were developing a new SaaS, just the evolution of the previous one. So we are a bunch of engineers are just working on Kubernetes and using Kubernetes during their journey. And we are distributed and splitting our application in microservices. So this is the story about what we are learning, because as you probably know, not everyone is used to work with containers, so there is also a lot of training and teaching and learning involved when you move to a more distributed environment. So I think that around distribution, the hard part is tracking it. So when you start to split your application in different microservices, or even if you're moving from a more static, maybe a single data center kind of situation to the cloud, when you have more data centers and your virtual machine just goes up and down and you don't know what's going on, that's hard. More your application is distributed across region, across data centers, more hard it is for you to understand what's going on. Luckily for us, we have some way to start and track what's going on. Metrics, traces, and logs. So they are both important. They are all important. You can have just metrics or logs or tracing. You need to have both. You need to have all of them. And metrics, for how I can see them, they are just a big slap in the face. So you are like, usually you are sleeping and you just get a slap in your face, and that's it. You don't know where it comes from. You just get one, and you open your dashboard. Usually, you have a lot of dashboard because everyone is really happy to look at the lines. That really doesn't mean anything usually, but everyone is really happy. And you get this lap, and you wake up, you open your dashboard, and you see these lines, and nothing. You just know that something happened. After that, you open your logs, and you look like these guys. I look like him too, and you are just looking for something. You have this big stream with lines that now are not graph, but they are lined with text, and they go so fast. I have a friend that usually back in the day he was debugging application, and he was using logs, and based on how far they was going, he was able to tell if the application was running well or not. So even if it was really, really fast, something was going really, really bad because we was getting a lot of traffic. If they was too slow, maybe something was not really good. So logs are really important. They have context, but they are not enough. Another kind of data that you can look for are traces. They are kind of becoming mainstream now with open tracing and all this kind of stuff. Obviously, traces are not new, but distributed tracing is definitely something that helps you to understand how your request goes into your system and how it behaves. So I have a section about traces that I will cover later. Obviously, this is not a one-shot kind of situation. You need to do that every time. So every new release, you need to instrument your code. It's part of your pull request. It's part of your review. So it's not something that you do once. It's something that is part of the culture of your team, and it should be part of the culture of your team to instrument the application in the right way. The secret is not about the data that you have, but it's about how do you combine them together. If you have just CPU, memory, disk I/O, you can have the granularity, the best granularity you can have, but we won't tell you the real issue in your system. So you have business, we can have a lot of metrics. You can get business kind of metrics, so the number of logins, purchase, or transaction. You have the CPU, memory, you have all the daemons are exposed in metrics. If you use Docker, you have the number of containers that are spinning up and down, or the RAM inside the container. If you use Kubernetes, you can get the distribution out from the kubelet. So we can get really a lot of metrics, but the secret is all about how we use them together, even different kinds. So you should be able to mesh together logs with traces. So if you use traces, be careful and put the trace ID in your logs. So when we look at the logs, you can get the trace ID and retrieve the trace ID from your tracer application. So the key is really about how do you combine them together and how you use them. This is really hard. Like aggregating metrics, it's really complicated. It's something that it's hard to plan before, because usually you learn about what you need when you have an outage or when something is not working. So usually the strategy is to get all the metrics you can get, and at some point you just end up with a lot of confusion. So it's definitely important all the metrics you get, but it's also important to tell the right question to the metrics you have to get the answer you need. So another important stuff that we learned during our development is that we use and we have a lot of third-party services. So we use a CI, we use Circle CI for CI, we use GitHub as a version control system, we use maybe you use a cloud mail server, we use AWS, so we have a cloud provider, and it's really important to understand how they behave. At least having an idea, because if GitHub is down or Circle CI isn't working for their reason, it's fine, but you need to know that and you need to take action. Probably you need to stop releasing your code for a little bit. And internally at Influx, in our current SaaS, we developed a feature that is called Co-Monitor, and we find it really interesting. So what we are doing basically is just sharing with our customer our metrics. So just a little introduction about Influx Cloud. Influx Cloud it's a SaaS platform, and so you can buy InfluxDB, the database, and all the tech stack, and we will manage it for you. So we will just get a URL, and everything will be managed by us. So we collect all the metrics from our proposal, so for monitoring, and we store them in what I call Influx Cloud Monitor. The Influx Cloud Monitor has a retention policy of 2 weeks. So after 2 weeks, all the data are gone. What we added in the pipeline was a capacitor application. Capacitor is an open source tool that you can hook to InfluxDB, and it stream or batch all the metrics, it applies math and other stuff, and you can do whatever you want with the result. So it's really used for downsampling data and move them around. So what we did was we are downsampling 5-minute batch of data in one point, and we are forwarding the point to another database that is called the co-working database, the co-monitor database. And our customer had, other than having InfluxDB, they all have Chronograph, that is the dashboard that we develop. So they have a pre-configured dashboard inside Chronograph they can look at, and it contains the data about their cluster. This is really good. I think that not everybody, a lot of third-party services that should do something like that, because we also allowed our customer to understand how their behavior changed the load in our cloud. Because obviously the cloud that Amazon or Influx Cloud is good, but it's not magic. So at some point you will reach the limit, and it means that you should pay more. So if you have the ability to understand how are you going, you can take decision. And another important stuff that we learned is that there is not a unique recipe about how do you instrument your application. So these days, there are plenty of libraries, plenty of languages, and a lot of companies are not using just Java or just PHP or just Go. They have different teams, and every team has different language. We use different languages, and they should be able to combine the results, for example, logs, stats, or traces, under the same format. Because if you don't have the same format, you can't build the trace. Analyze logs is harder. So the idea is that you should also invest time in your instrumentation code. In how do you instrument your application? And this is obvious if you think about how we started. So we started from the fact that instrumentation is part of your application. So you need to treat that code as all the others. Even because if you look at if you do proper instrumentation, so you have a tracer library, you get traces from your application, you get stats, you expose metrics, you will end up having a lot of instrumentation code. So you need to be careful about how you use it. So different languages, based on the people, so the team that you are working on, and based on the scale you are, the instrumentation libraries are different. This is a trace. This is something that it's a Zipkin trace. So if you come from the Java world, you probably know that there is a popular tracer started by Twitter that is called Zipkin. So you can inject the SDK in your applications, and it will send all the span to the tracer, and the tracer will build this trace. So as you can see, all the services are listed one by one. So this is a trace. Doesn't matter which tracer do you use. So usually you have all the services. This is one specific HTTP request. So let's say this is your purchase in your e-commerce. So this purchase flows to different services, because you maybe have the front end, and you have the authorization service, and you have the I don't know, database where you check if there is availability, and you mark the purchase, and you generate the PDF for the invoice. All this kind of stuff are different services. So the trace is helping you to tell the story about a specific request. So every request has an ID, and you ask for that ID at the tracer. The tracer give you back this stuff. And the idea is that you can understand how it goes, which services is taking too much time, and usually there are, I have slides later, but it's also change color based on the behavior. So error has a different color, for example. It's really important. I think it's important to kind of agree on a common standard when we speak about traces. And I come back at the sentence that I already saw before. If we have different languages, different teams, and we are not able to send all the spans with the same format, we won't be able to create a tracer in a easy way. So the idea is that if we should all agree on something, it will be easy, and it won't be a vendor lock-in, because if all the vendors support the same standard, we can switch them easier. So the CNCF, that is the Cloud Network Foundation, comes with this standard that is called Open Tracing. And there are instrumentation libraries for a lot of languages, so PHP, Java, C, Go, whatever, has a instrumentation library for that. And the architecture is easy. Well, this is just some common languages that we should use. So a trace is made of spans, so every line is a span. And you can attach key value store to that span. So let's say that one of your specific span is it's measuring the database, the interaction with the database. What you can do is you can pair the query inside the span. So when you retrieve the trace, you can just see which query is causing trouble. There are also key value pairs that you can use for the HTTP request or HTTP status and whatever. So there is you can attach logs. As I said before, this is a nice feature because you're kind of bringing together everything. So you have your traces, and all the logs that are part of the trace are marked as a part of the trace. So when you retrieve the trace, you have the logs for that request. That is really good because in a distributed system, it's really hard. You have a stream of logs, but you don't know where it comes from because there are concurrent requests, so it's hard. The span context is the part of the span that gets serialized and moved between applications. So between applications. So at the end of the trace, you can enrich your span context with everything, all the flow you have, and the tracer is the backend that you use for your library. So you instrument your application and you attach the tracer. There are plenty of them. Some of them are open source, like Zipkin, the one I told you before. There is Jaeger, that is like the porting in Go for that application. Lightstep is as a service kind of company. And AWS has its own one, X-Ray, that support open tracing. Google has its own, so there are a lot of them. And all the tracers support different backends. Usually the backend are Elasticsearch, Cassandra, or InfluxDB, just because they handle better high cardinality data. So as I told you, you can attach key value store, and you are free to do whatever you want with that key values, but some of the keywords are fixed, and they are fixed because the tracer can use them to build a UI on that, or if you apply math on them, you can calculate latency, and you know that those are the pair that you are looking for. So for example, the most common one is the error one. So if the error is true, your span will become red or a different color, so you will know that that's the bad actor in your request. So that's how, from an architecture point of view, it looks like. You have your application, your microservices, or your Lambda function, or whatever you have, and you inject the SDK into your application, and that SDK has a tracer, and that tracer is the backend that you should reach. So the good part is that if you need to, for some reason, you need to change the tracer, maybe because it's too expensive or it's not enough powerful for your scale, you can just hook a different tracer at the top, and your instrumentation code will stay as it was. So there are a lot of standards. Open tracing is just one. I'm showing this one because I just think it's good, and I also think that you should have just one. Take the best you can or develop yours. I don't care. Yeah, another good part about the open tracing standard is that it's well adopted across languages and across open source tools. So Spring has its implementation. gRPC already hooks open tracing natively. There are a lot of tracers, and Ruby, Go, Java, Python, Objective-C. They have all the support for open tracing. So it's good because you just pick a language and you know that it will be covered in some way in the community. So obviously, not all the combination works well. So internally at InfluxDB, we use Go. So we tried Zipkin because we was kind of we had it under our hands, and we discovered that they don't play really nice. Obviously, I don't say that really loud because we didn't have time to understand why they didn't play that nice. So probably if we had time, or if we will have time to profile and get some debugging, we can probably fix the memory leak. But it's not something complicated because luckily all the instrumentation library are kind of small. So if you work in Go, maybe you can go with Jaeger because it's in Go. It's also linear, but we didn't think about that at the beginning. If you work in Java, Zipkin works really well, and the instrumentation library works really good. So you can go easily with that. Jaeger and Zipkin doesn't support InfluxDB yet. They are all open source projects, so maybe they will be, but at the moment they don't. And we love to reuse our code. So we was willing for a solution that it was kind of usable with our tools. What I did, yeah. But open tracing is designed to be extensible. It's just a spec. If you look for the project on GitHub, it's just a list of markdown that you need to read. So there is nothing, no code involved. All the code are just made to make it friendly and make it usable. But it's just a spec. So it's extensible. Log is a transport layer. So other than being really a rich way to understand what's going on, it's also a really easy way to move data between stuff. So what we did, two of my colleagues, really smart dudes, they did a kind of side project during the weekend, and what we ended up to do was to write a new open tracing compatible tracers that was enriching our logs with the all the span keeper and all the things that I told you before inside the log. So now we have all this stuff inside the log. We don't have a database, so we don't need them because we just forward them in that centralized log place. What we do is we use paper trail for that. So with a simple paper trail CLI plus some pipe and bash, we was able to take a trace and push the trace in Jaeger and have the nice visualization for that. So as I told you, we are under heavy development now, so we don't really know what we went up to use as a tracer at the hand. We still have a couple of months to figure it out. But in the meantime, we knew that we know that traces are important to figure out what's going on. So we just end up with this hacky solution that works well, and it's not really, and it doesn't require a lot of maintenance. So I thought it was a nice idea to share. So at the end of the story, as I told you before, it doesn't matter if you have traces, logs, events. You should have them all. You should have all of them. You should have them all together, and you should be able to use them and combine them together. So what you are really looking for at the end of the story is just a high cardinality database. So it's a database where you can put all the data inside, doesn't matter the format or whatever, and you can query them in a smart way and making the right question and getting the right answer. So cardinality is a database concept, and it has a lot of meanings. This article just from Vivid Cortex just summarized some of the answers that you can get about cardinality, but the one that I'm looking for is the number of distinct values in a table column. So relatively of all the number of rows that you have. So it's the single value you have in your table. So all the databases has limits, so even the databases that are really good handling high cardinality data usually reach a limit. They are not magic, sadly. And what you can do to avoid this problem or mitigate the problem is downsampling data. As I showed you before, the same that we do for Influx Cloud, you can do for your data. So you put all the data in a short attention policy, and after 2 weeks, you sample them and aggregate them together, and you do that until you reach the point that you just delete them because you don't care. Another important feature that you should look for when you look for a time series database to have your monitoring is the data retention. Usually, if you look for SQL database, or all the delete are made sequentially, so you make the delete, but the engine is just taking one row and deleting row by row all the rows. So this is not really the best solution when you need to remove frequently a lot of data because they get old and you just don't need them. So you should look for a database that implement the retention policy in the way you are looking for. When you speak with the time series. So for example, InfluxDB is able to delete file from disk. So the file contains all the points that are older, and when the database detects that they are too old, it just delete the file from the disk. So it's not expensive, has deleted one line by line, one line by one. So before coming here, I counted how many metrics we are currently storing in our InfluxDB, and we have 310 distinct metrics, and they come from everywhere. Like we have an agent that runs in every server, so it gets CPU, memory, and we watch for Docker daemon, so we get all the metrics that Docker give us. We use Kubernetes, so we watch for the kubelet, and we have all the kubelet metrics. We mark the deploys because they are really important. Every time that our code goes in production, we are not in production, but we have an environment that we call production. So when our code goes in production, we mark the deploy because we also discovered that something really new. So I'm going to say something shocking here. We are usually the bad actors in our production system. So as a developer, we are the people that makes trouble. And so marking the deploy is really important because it's where your code change and where your behavior change. So if you mark your deploy in your, for example, in your dashboard system, you can see the graph change. If they change in a way that they are not supposed to change, you can roll back. So we also mark the business kind of metrics like the number of login, or how many writes and how big they are, or how many reads we get and how big the query is. So what are you looking for? I think it's also it's kind of hard because all the data that you collect are not they don't answer the hand question you will have. They will just part of the process to answer the question, but you need to understand how to make them together. So it can be kind of hard. And yeah, it's hard to understand what matters because when you have CPU, memory, and it's just hard to combine them together. I don't know how to say that, but it's hard. And what the metrics to look at. So what you probably look for is also a fast way to iterate on your collector. So we have a collector that runs in every node, and we use Kubernetes, so we have this concept of daemon set. So we can tell to Kubernetes, take this pod and run this pod in every server and keep it up. So we developed an open source collector that is called Telegraph. It doesn't work, it works also with other databases, not just with InfluxDB. So you can hook it to Graphite or CloudWatch or whatever it's supported. I think that there are like 20 of them as a output. So it's all based on plugins, the concept of plugins. So you have input plugins and output plugins. The input plugins are the one that gets the metrics from other system. So you configure them to scrape stuff from Prometheus entry point, or to get metrics from MySQL, or to get metrics from your application. And it also gets stats metrics from your node and so on. So I think that when you need a new metrics, you need a new metrics right now because it's already too late if you don't have it. So have a good way to iterate on the collector. It's also something that you should probably look for at some point. Telegraph is really good. You can just fork it, and all the interface that you need to implement to get metrics are, I think, 1 or 2 functions. So they are really simple. It's really simple to write your plugin, your input plugin. Another topics that we find hard is all the alerting kind of situation because it's also related about how you aggregate data, because you can alert on CPU only or memory only because you don't really care. I mean, I don't really care if a container goes out of memory if Kubernetes can bring it back. So if I receive an alert when my container goes use too many CPU, I don't care because I have Kubernetes that cares for me. So I don't need to wake up. And that's why the aggregation that you do are also one of the best answer for your alerts. So you have your aggregation, you put together the number of writes with the CPU and the memory, and you can kind of you also put together how frequently Kubernetes restart a pod, and with all this tunnel you can at this point make an alert, because if you used too much CPU and Kubernetes is restarted the container too much time, at this point maybe you need to receive an alert. But it's not one signal the answer, so you need to have more. Yeah, to make everything more realistic, and that's why we are not in production, but we call our environment like production. You need to work under some pressure. So not that pressure, a different kind of pressure. And we use GoReplay for that. So luckily, we already have a cloud system that is working. So what we are doing, we are forwarding all the traffic or part of the traffic or what we need based on what we are testing from the old environment to the new environment. GoReplay is just a Go binary. There is also a company behind it, so you can ask for support if you need, and that you run in your node, and you can say, okay, forward this traffic to this other entry point, or forward that to S3 and just replay it every time. So that's what we do. And we learn a lot of interesting stuff. So first, we are learning how we should operate our code, and we are learning it in real time because we don't have real users, so nobody's going to boring us. But we treat this fake traffic as a real user, so we know who's going to have trouble when we deploy, or if we change something, we know how it behaves under traffic. So it's like having constantly a stress test running under your head. And this is good. Obviously, sometimes what you need is just a quiet place. So we have also a way to stop all the traffic or to have an environment that doesn't receive traffic because maybe you need the right amount of traffic to test how it behaves. So obviously, you can't do that with random traffic. But we can learn a lot of stuff in this way. Yeah, instrumentation is part of your code, is part of your work as a developer. So I told you that before, and I won't stop ever to say that. So it's part of your code review process. When you look for the process, you don't look just for the business logic. You don't look for the style. You don't look for the semicolon at the end or how many tabs it has. You look also for the instrumentation code and how it is instrumented. So it's really good to ask for feedback because usually when you develop a feature, you always miss, or you are more concentrated on some part of your pull request. So somebody else can say, okay, maybe you should instrument also this part, or you should also add some metrics on that pieces because it can get useful. So it's really good to have in part of the culture the idea to review which metrics do you get. Another important point of view other than deploy is how fast your team codes. So how long a pull request stay up, stay open and doesn't get closed. It's also a good metric that you can kind of leverage to understand your feature velocity during development. At InfluxData, we have this kind of rule where everything comes with a slash metrics, and we use the Prometheus exposition format to get some of the to expose some of the metrics. Obviously, it doesn't apply for every metrics, but it applies for a good amount of them. And for example, obviously, if you have for example, the right path that receive a lot of data, is really hard to expose them in a counter because maybe you need a different, you don't need pre-aggregation. You need a precise point in time. If you work with Prometheus, you know that everything that it exposes, it's pre-aggregated. So because you pull them every 10 seconds. So if you need a point in time, it's really hard to get with Prometheus. So in that case, we push data to InfluxDB directly, or we use Telegraph as a middleware to collect all the data and send them to InfluxDB. So the Prometheus exposition format doesn't apply for every kind of metrics, but it's definitely a good start. It's definitely a good stuff to have in your service. Yeah, as I said before, some metrics are better to be pulled, some metrics are better to be pushed. Doesn't matter. They work great in all the cases. And something that we also discovered is that it's if you use InfluxDB, you probably know that it supports TCP and UDP traffic. And if you never ask yourself why, I'm gonna tell you why. The reason behind that is because the throughput, the difference between throughput between UDP and TCP is really high. So you can send a lot of a lot more metrics in UDP than in TCP. Usually, you don't get. You are not sure that the point will be stored, but you can send them all the way down without caring. And the good part about UDP is also that if you don't really care, obviously, if you are monitoring the heartbeat of my body, and you need to be careful about what's inside the database. TCP is the way to go. But if you are monitoring, CPU or whatever, if you miss a point, doesn't matter because you can calculate it the next iteration, and you usually don't alert if after 10 seconds you don't receive CPU, maybe a little bit more, and you have other metrics, as I told you before. So in this case, if you use UDP, your network is gonna slow down compared with TCP. So pull versus push doesn't matter. UDP, TCP doesn't matter. Obviously, you need to pick the right one for your metric. Another important point is that you should monitor your monitoring infrastructure. It's gonna be complicated. Obviously, it really depends on your team and how big your company is, how your team is good on this kind of stuff. So as I told you before, I just think that you should have a monitor even in the paradise, but doesn't matter. But you can also outsource it. So just be careful about who is gonna handle your data. So there are obviously some. It's really important to monitor your infrastructure and it's also important how do you architect your monitoring infrastructure because it can't go down with your environment. That's like a requirement because if your production goes down, your monitor goes down, you just don't get any alert. So everything works, but nothing works in reality. So it's not an easy job to maintain a monitoring infrastructure. That's why probably having a partner that does that is a good idea. Obviously, to avoid that, the monitoring infrastructure should be as far as possible from the environment that you are monitoring. So there are a couple of strategies, like different cloud providers, different data centers, different companies. So different regions, different teams, whatever, as far as you can go with difference from what you are looking for. So this was our journey. Our story is never ends because development never ends, so we don't know how it will be in the future. But I hope that what I show you kind of open your minds around what you should do or not do with your distributed application. So thank you.
Thank you very much, Gianluca.
Thank you. I have a couple of time for questions, or I will be around. So
we do have some minutes left. We can start with some questions here, and right after these sessions, there will be the backstage track also with Gianluca,
yes.
Together with Aaron and Russ. Some of you know him from yesterday. So, are there questions right away?
Be kind. Yes.
Just for sake of curiosity, what about the overhead to have such kind of matrix? I mean, we know that Zipking, Jaeger, and so on are introducing a sort of interceptor or something like this, and Prometheus, you can use what is coming, for example, from Spring Actuator and so on. But you can also instrument your application to produce more metrics, more specific metrics and traces based on your needs. What about the overhead? I mean, how much? I mean, we saw a sample of trace. How much is the impact of putting traces and metrics in place? On a normal, I mean, just if you know an example or something.
Yeah, I mean, I think that how you should usually start. It's always, as you said, you are gonna end up having a lot of data in a really short amount of time. So we are developing our system since a couple of months, and we already have 300 metrics. So you can really handle a lot of data. So the strategy should be that you should start with the first entry point should be a really short retention policy. So in this way, all the mass that you don't usually use go away in 2 days. So all your infrastructures that enter those data doesn't have a lot of pressure because after 2 days, doesn't matter how many data you are sending, you can manage 2 days of data. I mean, it's a number that you should choose. But the idea is that you should have a really short retention policy at first, and you should downsample them later based on what your experience. So if you see that you are using a metrics every day, every time, because that's the metrics that it's really important for you, maybe you can downsample all the others and not that one. So it's like steps that can help you handling that. Other than using retention policy a lot, I think that yeah, for example, traces are really hard to downsample because you need that granularity. Maybe CPU or other metrics you can downsample them in an easy way because you just care about if you take every 10 seconds after 2 days, you just care about the half an hour, the 10 minutes, so you can delete points. For traces, it's hard. So there are projects, and I know there are some guys that are working on a way to downsampling them, but I don't have the answer yet. So. But yeah, just use retention policy. Different buckets, 2 days the first time, and you downsampling them, or you remove them if you don't care. So in this way, the infrastructure won't be too under pressure.
Thank you very much. So I suppose one more question, and afterwards we'll move on.
Okay, thank you.
With the questions to the backstage track. Sorry.
I will be around, so just stop me.
Yeah, just a quick question. So you haven't really talked about the alerting part. So do you think it's sensible to collect metrics without ever alerting on them?
Yeah. Oh, sure. Yeah. You never know which kind of answer you will will to have from your monitoring system. So I definitely have plenty of metrics that I don't alert from, but they are useful to answer the troubleshooting question I have when I'm debugging. So yeah, I think that the best signal that you can alert on is really hard to have because it is made from a lot of combination of metrics. So I didn't speak about alert that much because we are still under development for the alerts. So we have some basic alerts, but we don't have the one that we should have or we are willing to have. So I think that, yeah, the best update I can say is that doesn't matter how many metrics you collect, you will always have some of them that won't be tied to an alert. That's fine, because you will be alert every second. So that's normal to have. And build the right alert signal is really hard. So it's really tied on your business case and how as I said before, also your kind of environment matters a lot, because as I show you, I don't really care about the memory outage if Kubernetes can handle that for me. So it really depends the tool that you are using, other than the business that you are making. So.
Thank you very much.
Thank you.
Give a round of applause to Gianluca. Thank you very much.
Okay, thank you.